Today we're going to talk about reflection, which is one of many transformations, and specifically reflection is a rigid motion or isometry. So the definition, please write this down. A reflection is a transformation where points remain the same distance from a line of symmetry on opposite sides. So in this diagram, that's the line of symmetry from here down to there. And P on the opposite side of the line of symmetry, the same distance away, is P prime. That's what makes it a reflection. So if I had another point here, because it's closer to the line, we will also be closer to the line on this side. So what that looks like is here's an object reflected, and the blue goes to the blue on the near side of the figure. This yellow is further away, and then you draw continuing there. Now, in order to connect this point to the line, we always go straight to the line, which means that these should meet at a right angle. So we can say that the line of symmetry is always perpendicular to the line connecting the pre-image and the image. Now, you've definitely seen reflection in real life. This is the cloud gate, sometimes referred to as the bean in Chicago. This is not really what we're worried about with reflection, but it gives you a sense of all the different things that we come to associate with the word reflection. Here is more of what we think of when we say reflection in geometry. And the reflection here is going to be across this line. And what you see is, okay, if we wanted to connect to that point, that's hard to see. That point and that point, those are corresponding. This was the real part, and then we connect it straight down to the line of symmetry, and then we could go the same distance on the other side, and that gives us our output. So if this was P, that would be P prime. Here's a diagram where there's actually more than one line of reflection. So the line of reflection that you see might not be the same one as it may not be the same as the one that someone else sees. There's this horizontal one, and then there's also this vertical line of reflection. I kind of missed, but it's there. So a diagram can have more than one line of reflection, but we'll only perform one reflection at a time. If we need to perform more than one reflection, we'll do one reflection, then the other, never both at the same time. So to perform a reflection, write these steps down. First, you will identify the line of reflection. So you have to figure out, usually it'll say, reflect over x equals 2. Well, you have to know where x equals 2 is. Then you draw a segment connecting the pre-image to the line of reflection. So if we have, this was our line of reflection, we draw a segment connecting the pre-image to the line of reflection. And now we continue the same distance on the other side to find our image. This step, identify the line of reflection, is something that we've been working on over the past few weeks of writing the equations of lines or graphing lines from their equations. But I want to make sure that we understand that because this is where most of the errors happen. So, please recall that a horizontal line looks like y equals, and a vertical line looks like x equals. So here we have, this is a vertical line, and it looks like x equals, and whatever the x coordinate is. In this case, it's -6. This red one is a horizontal line, so it'll look like y equals, and it crosses at 4, so it's y equals 4. This is called the y-axis. And the equation of the y-axis is actually x equals 0. This is the x-axis, and the equation of the x-axis is y equals 0. So if you need to review these, definitely come see me and we can review these, but horizontal lines are y equals, vertical lines are x equals. So if we wanted to reflect across x equals -4, well, we would have to first graph -4. This is the line x equals -4. And then this is, let's see, that's the segment connecting the point to here. So this is a distance of 7. So I have to actually go another 7. 1, 2, well, it's not really easy to see, but somewhere over here is going to be w prime. And we want that distance to also be 7. So if we were over here at -4, we would have to go another 7 left, which would say that this is out at -11. So this coordinate would be -11, comma, -1. I got the -1 just because this was already -1. So this is how I can reflect. I count to the line, and then I count past that line. All right, across y equals -1. Here is the line y equals -1. Y makes it horizontal. And -1, we travel 2 down to -1. So we need to travel another 2 down to where our output is. And our output will be called k prime. Reflect across the x-axis. Well, the x-axis is also y equals 0. And that's the line here. So we'll have to do each point separately. I think that's the easiest way to do it. F doesn't go anywhere. G is 2 away, so it'll go 2 away on the other side. So there's G prime. And E is 4 away, so it'll be 4 away on the other side. So there's E prime. And that is E prime, F prime, G prime. And it should look like the reflection. Lastly, let's reflect across x equals 1. X equals 1 is vertical. This is where x is 1. So now let's connect these. V is 2 away, so we need to go another 2 onto the other side. Note that I'm going 2 away from the line of symmetry, not from the axis. This is 2 away, so we have to go another 2 to w prime. This is 4 away, x is, so we have to go 4 away to x prime. And then our answer is that triangle. X prime, v prime, w prime. All right, that's how you perform reflections. Thank you.